is going to be about the last operation in vectors called the cross product or the vector product of two vectors. Last couple of sessions we have discussed about the scalar product or dot product and seen some of the applications of that, including projection of vectors, etc. Now we move on to the very last type of operation in vectors. We've done addition, subtraction and scalar product before this, but now we look at what is called cross product. That is the name of the operation, the cross product, or also called vector product. Applied to two vectors. So the symbol used for this operation is the cross symbol. Okay. And if we put a cross symbol between two vectors, it is read as cross product or vector product of the two given vectors A and B. The definition of this is that E cross B equals to EB sine theta multiplied by a certain unit vector given by the symbol n cap. Where on the right hand side, E is nothing but magnitude of the vector E, B is nothing but the magnitude of the vector B, theta is the angle between A and B, and n cap is a unit vector which is perpendicular to the plane containing E and B. In other words, n cap is perpendicular to both vectors A and B. So this is the definition and notation for the cross product. Just make a note of it as we look at this with the diagram, etc. We'll understand more about this. Yeah, Shikha, the definition is written in front of you. A cross B is given by that formula, AB sine theta n cap. Just make a note of the definition, please, everyone. Okay, so now let us understand more about this n cap thing. Okay. But before that, let's understand few general important aspects about it. Okay. So E cross B, unlike E dot B, is a vector quantity. Okay. It is not a scalar quantity. A dot B was a scalar quantity. That's why it was called scalar product. But E cross B is a vector quantity. Secondly, E cross B is a vector quantity such that the magnitude of A cross B equals to A into B into sine theta. Okay. So the magnitude of the cross product of vectors A and B is given by this relation. It is AB sine theta. Okay. Now, if you look at the quantity AB sine theta, you realize that it actually represents the area of the parallelogram formed by A and B. This is the vector E and this is the vector B, and the angle between them is theta. You'll also realize that this area, if you drop a perpendicular here, this height is nothing but B sine theta, and the base is nothing but E. So the area of this parallelogram formed by the vectors A and B is represented by the quantity AB sine theta. So mod of A cross B, which is AB sine theta, this represents the area of the parallelogram with sides A and B. This quantity, it is base into height. Okay. Or you can also think of it as 2 times the triangle formed by vectors A and B. So this is part of understanding the definition that it is a vector quantity जिसका magnitude क्या represent करता है, area of the parallelogram. Okay. We'll come back to the direction. First, write down this information. Hitanshu, there's nothing to understand. You have to just note this down. Just note down this thing that A cross B का magnitude क्या होता है, by definition AB sin theta होता है, और AB sin theta क्या होता है, it is base into height of the parallelogram. So it's a common thing in geometry. You should understand that base into height is nothing but area. There's nothing extra to understand. You have to just note down this is the definition. Okay. Finish noting down, people. Okay, now next thing, the direction of A cross B. Yeah, what happened, Hitanshu? But what? Tell me. What you have not understood? Yeah, Hitanshu, I'm waiting for your point. What triangle? बेटा कहाँ triangle draw किया? मैंने parallelogram draw किया है. इसमें height कितना होगा? B sin theta होगा ना बेटा? If this quantity is B over here and this angle is theta, when you drop a perpendicular here, what will this perpendicular or this height be? It will be B sin theta, ना? ये तो trigonometry है बेटा. ये तो आप कितने दिन से मैथ्स में भी कर रहे हो. ये साइड कितना है? B है, ये हाइपोटेन्यूज है, तो ये परपेंडिकुलर कितना होगा? B sin theta होगा. So that is why the height, the vertical height of this parallelogram is how much? It is B sin theta. The base is how much? It is A, because the base vector is A. Understood now? Okay. Okay. Now the third thing, the direction of A cross B is given by the unit vector, okay, n cap. Now n cap का डायरेक्शन क्या होता है? n cap is perpendicular to both vectors A and B, okay, and very important, is determined by right hand palm rule. So I'll explain what right hand palm rule is. Now see, if I have a vector A which is like this and another vector B which is like this, now in this diagram you can see that both the vector coming out of the plane of the screen and the vector going into the plane of the screen are perpendicular to A and B. So if I consider a vector जो कि ये व्हाइट बोर्ड के स्क्रीन से या आपके डिवाइस के स्क्रीन से कमिंग स्ट्रेट आउट टुवर्ड्स यू. Okay, imagine an arrow coming straight out towards you. So that is perpendicular to both A and B. Similarly, think of an arrow going straight into the plane. Okay, an arrow that is headed straight into the plane, perpendicular to the plane. That one is also perpendicular to both A and B. So then how do we decide whether n cap? Okay, so therefore, the direction of n cap, whether it should be into the plane, okay, or coming out of plane is determined by right hand palm rule. Okay. So whenever we look at two vectors like this, A and B lying in the plane of the paper you are drawing in or lying in the plane of the board in which you are seeing, you want to represent n cap as a vector which is perpendicular to both A and B. तो आपके पास दो ही ऑप्शन होते हैं, either the vector n cap is coming out of the plane or the unit vector n cap is going into the plane. Now how do we decide which of the two it is? So for that we have something called the right hand palm rule. So next let's understand what is the right hand palm rule. So for the operation E cross B, okay, to determine n cap, what we do is place your right hand palm such that the thumb is extended in vector A's direction. Okay. And the fingers are pointing towards vector B's direction. Okay. Then the direction in which the palm faces is the direction of n cap. Okay. So just before you note this down, just go through this statement once and I'll explain to you with an example. Okay. Just go through this statement first. Okay. I will give you enough time to write all this down. Then I'll explain to you. Don't worry. No, we can't take the cross product of more than two vectors like that today. We are taking only two cross product of two vectors at a time. I'm not discussing the operation A cross B cross C. Okay? We are doing A cross B only right now. Okay, so let me explain this physically. Okay, just give me a second. Okay, so hope you have read the statement carefully. Now let me explain what the statement means. Okay, so see here. Okay. So all of you can see that if you are having two vectors A and B like this, okay, then how we will determine the direction of the cross product? You point your thumb along the vector E because I'm doing A cross B. Okay, so your palm should be oriented in a way that you point your thumb along the vector E and your fingers along the vector B. So where your palm is pointing now, it is pointing outwards. Your palm is facing outwards. So तो इस केस में ए क्रॉस बी का डायरेक्शन क्या होगा? कमिंग आउट ऑफ द प्लेन. ओके, so coming back to this example now. So for example, when I had this situation that E was like this and B was like this. Okay. As we had seen last time also, you place your thumb in the direction of E and your fingers in the direction of B. You see your palm is facing outwards. So what is happening? N cap is coming out of the plane. Okay. Whereas next, let us look at an example where suppose we have something like this. Vector E is in a direction like this. Vector B is in a direction like this. Now tell me what should be the direction of A cross B? Going into the plane or coming out of the plane? Just try this out yourself first, then I will show it on the same. This is a little bit tricky, so I'm just demonstrating it on a physical pen and paper. But first you try and tell me yourself. Yes, that's correct. Amay, that's correct. Salman, that's correct. Shikhar, correct. Hitanshu, correct. Yeah, Pratham, correct. Rudra, correct. Shwetal, correct. Okay, Anay, correct. Good. So all of you are getting this. But anyway, I will just demonstrate. Yes, Anish, correct. Good. So I'll just demonstrate once more. So this time you can see that the vector E is along this direction, right? And the vector B is along this direction. So मुझे अगर A cross B निकालना है तो मुझे क्या करना पड़ेगा? I'll have to place my fingers along B like this and my thumb along A like this. So for this cross product E cross B, I'll have to place my palm like this. Understanding? I have to place my thumb along A and my fingers along B. So where my palm is pointing, it's into the plane of the paper. So that's why the n cap's direction in this case will become into the plane of the paper. Okay. So that's how we understand that here the sense of n cap will be into the plane. So hence the direction of A cross B n cap will be into. Okay. So this is how we understand whether something is into the plane or coming out of the plane. Okay. All right. Now moving ahead. So we have done some practice with this last time also, coming out of the plane and going into the plane. Now next thing we'll see is coming back to those points that we were writing down about. Okay. So we had seen the direction of n cap. That was our third point that is given by right hand palm rule. Okay. Now next thing we'll see is that E cross B becomes a null vector if theta is equal to 0 or theta is equal to 180 degrees. That is for collinear vectors. That is vectors which are lying along a straight line. Okay. Or parallel or anti-parallel vectors. Okay. And you can also understand, so geometrically, okay, collinear vectors do not form a parallelogram. They don't enclose any area. So if I have a vector A like this, another vector B, which is either opposite to it or parallel to it, it does not enclose any area. So that is why it becomes a null vector. Okay, so hope this point is very clear. It's very obvious. AB sine theta, when theta is 0, sine 0 is 0, as you know, and sine 180 is also 0. Okay. Now next point. Okay. A cross B and B cross A have opposite direction. So for example, if this is the vector E and this is the vector B, so we'll see that in the case of A cross B के case में, how we'll have to orient our hand? We'll have to orient our hand such that our thumb points along thumb points along A, and our fingers point along B. So what will happen here is our palm is facing outwards. So A cross B will be in which sense? It will be coming out of the plane. Okay. N cap is coming out of the plane. Whereas if we are doing B cross A, okay, in the same thing, if we are next doing the other operation, we are doing the operation B cross A. So what we do, whichever vector is before the cross sign, that is where our thumb points. Okay. And whichever vector is after the cross symbol, that is where our fingers have to point. Okay. So now we have to orient our thumb like this and our fingers like this. So then this will be the side of our knuckles. So our thumb will have to point along the vector B, and our fingers will have to point along the vector E. So that's the palm is into the plane. Okay. So for B cross A, the direction will be into the plane. Whereas E cross B, the direction is coming out of the plane. So they have opposite directions. For any two given vectors, if A cross B is coming out, then B cross A will be going in. If A cross B is going in, then B cross A will be coming out. So always they have opposite directions, but equal magnitudes. Okay. So in other words, we can say that B cross A as a vector quantity is equal to minus of A cross B. And magnitude of B cross A is the same thing as magnitude of A cross B. Yeah, explaining it. Yeah, Hitanshu, there are a lot of questions in your module also. Plus, I'll be giving you worksheets, so you'll understand how to solve questions based on this. But first, understand all the points I'm explaining in detail over here. There's a reason why we are going in a certain order, because you have to learn these things in a certain order. Then only you can start coming to the questions. So note down this point first. So this becomes another important aspect about cross product. That B cross A is minus of A cross B. Yeah, Shikhar, to explain the B cross A again. देखो यहाँ पे अगर मैं B cross A calculate कर रहा हूँ for these two vectors, then I have to orient my right hand such that I place my thumb along B and my fingers along the vector A. No? So how B cross A will be pointing? It will be pointing into the plane. Whereas if I am doing the operation A cross B, then my thumb should be along A and my finger should be along B. Yeah, because so Pratham, in the second diagram, that thumb and fingers get reversed because I am doing B cross A. So always whichever vector, suppose I am doing this, then whichever vector is before the cross product, that is where your thumb should be. And whichever vectors after the cross symbol, that is where your finger should be placed for the right hand palm rule. Similarly, if I am doing, let's say, D cross C, then your thumb should be along D and your finger should be along C. Okay. So similarly, if I am doing B cross A now, so क्या होगा? ये उल्टा हो जाएगा ना? Your thumb will be along B and your fingers will be along A. Because when I was doing A cross B, your thumb should be oriented along A and your fingers should be oriented along B. Okay. So that is a rule of the right hand palm rule. Actually. That is the principle of the right hand palm rule, that when we are doing one vector cross product with second vector, your thumb should be along the first vector and your finger should be along the second vector. So that is why B cross A becomes minus of A cross B, because it's opposite in direction but same in magnitude. No, it is not left hand palm rule, right? It is right hand palm rule. I have not कहीं पर मैंने left hand palm rule लिखा है क्या हितांशु? Then why are you asking like that? But this principle I have written down here, no? Shikhar, this principle I have written down, that B cross A is minus of A cross B. Okay. No, figure it that it should be going into the plane. And place your right hand like this. You see that you're looking at the knuckles. Place your thumb up like this and your fingers like this. Your palm is pointing into the plane. Right hand thumb. Don't use a left hand. Is it clear, Anil? See, Anil. Point your thumb like this and your fingers like this. Your palm is going into the plane. You understanding? That's the second figure. B is like this, A is like this. So B cross A going into the plane. Anna, is it clear, beta? Okay, good. Yeah, so you have to be a little careful about this thing. Okay? So this is the property. Hopefully all of you understood now. Now moving on to the next property of cross product. The next point, if we do this operation, A cross of B plus C, we can express it as A cross B plus E cross C. Okay. So this is what is called the distributive property. Okay. So this is like a normal algebraic operation. A is cross product with the sum of two vectors, B and C, can be written as A is cross product with B plus A is cross product with C. Just make a note of this. Okay. Now let's come to the very important thing of cross products in component form. So if you look at a Cartesian coordinate frame, if you look at it strictly two-dimensionally, you'll see if your x-axis is like this and your y-axis is like this, then the z-axis is coming out of the plane. It's coming out of the plane. The negative z-axis is going into the plane. Or if you look at it in a slightly three-dimensional kind of manner, you'll see that so if this is the floor, the room in which you're sitting, and you would represent this as your z-axis, this is your x-axis. These are mutually perpendicular planes. So if this xy plane is the wall into which you're seeing straight ahead of you, then your z-axis is the axis coming out of the plane, okay, on the floor towards you. These are the mutually perpendicular. Y is perpendicular to z. Z is perpendicular to x. And x is perpendicular to y. These are the three mutually perpendicular planes. But we always orient them in this way, that if x and y are drawn like this, then z is coming out of the plane. So therefore, from this diagram, now you'll understand the relations below. That if you do the operation I cap cross j cap, what we'll get? So see, I cap is like this and j cap is like this. So cross product will give us what? You'll have to place your thumb like this and your fingers like this. Okay. So your palm is facing outwards. So this will give us which direction? K cap, coming out of the plane. So how we get this relation? That magnitude of I cross j is 1 into 1 into sine 90, because they are mutually perpendicular unit vectors, so that is unity. And direction of I cap cross j cap will be along positive z axis, so that is plus of theta. So that's how we get this relation. So just make a note of this first, then we will look at the other possible cross products. So this is very important to understand. If we draw an x and y axis, the z axis is always drawn in such a way that I cross j gives you the direction of k. Yeah, Pratham, so the XYZ axis is drawn in such a way because we use what is called right-handed coordinate frame. So it has to follow the right-handed palm rule that X and Y axis are drawn in such a way that the Z axis is always pointing along X cross Y, or K cap is always pointing along I cross J and not the opposite. Okay, so next thing is, if I cross J is K, then naturally J cross I will become minus of. Okay. This simply comes from the property that A cross B is minus of B cross A. There is an inverse relationship between A and B. I mean between A cross B and B cross A. Okay. So since I cross J by definition is K cap. Okay. So what this implies is that J cross I must be equal to minus K. So this is the first set of formulae that you have for the cross product in component form or the unit vectors. Now similarly, you will observe what happens is that if you take J cross K, what we'll get here now, try to observe. So imagine that three-dimensional system. So this is your positive Z axis, this is your positive Y axis, and this is your positive X axis. They are mutually perpendicular. Now do the operation of J cross K. So what we'll have to do? You have to place your thumb along the Y axis and your fingers along the Z axis. So how your palm will be facing? Your palm will be facing along the X axis. So your palm is facing this way. When you put your thumb and your fingers like this, so this should be positive of I cap. Okay? And therefore K cross G will become negative of I cap. Again because of the same reason. So I cross J is K and J cross I is minus K. Similarly, J cross K becomes I cap and K cross J becomes minus I cap. Okay, so hope these two relations are clear. And now similarly, we'll see, we take the relation between K and I. We'll see K cap cross I cap. This will come out to be how much? So let's draw the axis again to understand this. So this is your y-axis, this is your x-axis, and this is your z-axis. This is the floor which you are sitting. Okay. So now if you do K cross I, how you'll have to orient your hand? You'll have to place your hand on the floor such that your right hand, that is, your thumb is pointing like this, and your fingers are pointing like this. So your palm will be facing upwards. This is where your thumb is facing, this is where your fingers are pointing. So your palm will be pointing upwards. That is along the y-axis. Okay. So that is why we have the relation that K cross I is positive of J, whereas I cross K will become opposite of this. So it will become minus of J. Okay. So we have these three kind of relations, that I cross J is positive K, J cross K is positive of I, and I cross K cross I becomes positive. Okay. So reverse of this also becomes that J cross I is minus K. Reverse of this becomes K cross J is minus I, and reverse of this becomes I cross K is minus J. So these are the cross products of unit vectors, of the standard unit vectors. Yes, that's why they are all given. Okay. So whether you take mod of I cross J, or mod of J cross I, or mod of K cross I, whichever you take, okay, that is 1 into sine 90. So that is unit. Okay, that's always the case. But it's the direction which comes according to the right-handed system. Yes, Bhumi, that's correct. Okay, so now I'll give you an easy way to remember these 6 formulae, because they get cumbersome sometimes. So you can just remember it by drawing X, Y, Z, or I cap, J cap, and K cap like this in cyclical order. So you can see that if you go along this cycle, you will get a plus sign. Okay. So I cross J, you're going along the circle, okay, along the clockwise direction. So you're getting K cap. j cross I, sorry, j cross k. So you are again going like this. So every time you are going clockwise, you get a positive sign. So I cross j, you get plus k. J cross k, you will get plus I, and k cross I. Again, you are going clockwise along the circle, so you will get plus j. Okay. But if you go j cross I, for example, now you can see in j cross I, you are going against the circle. You are going anti-clockwise, so you will get a minus sign. So this will become minus k. Similarly, k cross j में क्या हो रहा है? In k cross j, you are going again like this. You can see you are going like this. You are going against the clockwise direction. You are going anti-clockwise, so you get a minus sign. Okay. And similarly, if you do I cross k, then you are going like this from I towards k. So again, you are going anti-clockwise. I cross k, you get a minus sign. So just remember, if you go clockwise according to the sign of this, then you get a plus sign. If you go anti-clockwise opposite to the arrow of this, you get a minus sign. So this x, y, z clockwise order. This is the easy way to remember. Clockwise order for plus sign, and if you go against the clockwise order, then you get the minus sign. Okay, so let us see the use of all this now in an actual question. So next, what is happening is, given the vector E is suppose 2I cap, and the vector B is I cap plus root 3 j cap. So first of all, find E cross B in component notation. Secondly, draw a diagram to represent vectors A and B geometrically, and use this to determine the magnitude of A cross B and the direction of A cross B. So this is a question. Just take note of the question first, then I'll explain to you how to solve. Okay, so I'll explain the first part, then you can work out the second part yourself. So in the first part, given that vector E is 2I cap and vector B is I cap plus root 3j cap, we can see that E cross B, this operation will become, I can replace A with this 2I cap, cross product with B, I can replace with this thing, that is I cap plus root 3j cap. Now next thing we can do is we can use distributive property. So this will become 2 I cap cross I cap plus 2 I cap cross root 3 j cap. Okay. So as you can see, this is something into cross product with the sum of two vectors. So it becomes the cross product of the vector E with the first thing here plus cross product of vector E with the second thing here. Okay. Now this term will become 0. Okay. Why? Because parallel vectors have a 0 cross product, and this term will become how much? 2 root 3 times I cross G. Now here we understand that I cap cross I cap is 0, okay, because they are parallel, whereas I cross J was plus. This you have seen before. Okay, so this becomes how much? This becomes 2 root 3 A cap, because this term here is determined from this. Okay. So my final answer A cross B in component notation becomes this. Okay, so note this down quickly, and then also do the second part of this. Draw vectors A and B geometrically and find and its values. The question is this only, better. The question is here. You have to find A cross B in component form. That's the first part, and the second part is I've written below. So just note down the solution and do the second part yourself. Try out the second part just now. The question's information I've written here only. Okay, the same thing above. The same information is there here. Okay, people, so hope you worked this out. Yes, magnitude is 2 root 3, that's correct, beta, Pradnesh, and the direction will be coming out of the plane, which will mean that it is along the z-axis. Okay, so if we draw a diagram here, you will see that according to this diagram, okay, in the xy plane, we talk about the vector E. It is 2I cap. So it is a vector of magnitude equal to 2 and it is along the positive x-axis. So the vector should be drawn like this. Okay. Let's say that is our vector E. So magnitude 2, it's along the positive x-axis. Now what about the vector B? The vector B in contrast is I cap plus root 3 j cap. Okay. So magnitude of the vector B is 2 and the vector B is at theta equal to tan inverse root 3 or 60 degrees with respect to x-axis. You can see B is like this. So magnitude of B is root of bx square plus by square and theta is tan inverse of by bx. So using these two formulae, we have got this magnitude and we got this direction. So coming back to the diagram, vector B यहाँ पे कैसे होगा in the diagram? Vector B will be along this sort of direction. So vector B will also have a magnitude of 2, but it will be at an angle of 60 degrees with respect to x-axis. Okay. So now coming back to our definition, what will be mod of A cross B? AB sine theta, that is 2 into 2 into sine 60. So that will be 2 root 3. And A is like this, B is like this. So direction of A cross B will be coming out. Okay. So that is positive k cap. So now you can see that what we got earlier from part 1 clarifies what we got. We got this 2 root 3 and coming out. Now in part 1 we had seen that A cross B in component form was 2 root 3 k cap. So that's the same thing. Magnitude of A cross B is 2 root 3. And direction is along positive z axis or plus k cap. So this is the same information that you're getting by drawing it geometrically. So it verifies the geometrical method also. Okay, so hope this is clear to all of you. Okay, people, so hope this is 100% clear. Now, on the basis of the same thing, like we did this question using the definition of cross product of unit vectors, the first part, like that now we will develop a general formula for A cross B in component form. So, next thing we'll see is general formula for E cross B in component form. So in this, the first thing we'll see is that if our vectors A and B are in the two-dimensional xy plane, then obviously your E cross B will either be along k cap or minus k cap. But how do we determine? So given E has some general x component Ax and some general y component Ay, and similarly B. Okay, so then E cross B will become Ex I cap plus Ey j cap, cross product with similarly Bx plus By. So next, when you open this whole thing using distributive property, so take the scalar quantities outside, I cross I. The first term, cross product with the first term here will give you I cross I. So that is nothing but 0. Then you have Ax By, but I cross J. So that will give you your K cap. The next term is Ay J cap. That is the second term of this bracket, cross product with the first term of the second bracket. Okay. So Ay Bx J cap cross I cap. Okay. And then finally the second term, cross product with the second term. So Ay By J cross. Okay. Now in this operation, we know that I cap cross I cap is 0. We know that J cap cross J cap is 0 because they are parallel vectors. And we also know that I cross J is positive of K, whereas J cross I is minus of K. So we know these things. Using this clockwise thing. We know this since they are parallel vectors. So use that over here now. So in this, we use this fact that this term will become 0. This term will become Ax By K cap. This third term will become Ay Bx minus K cap because J cross I is minus K. The fourth term will again become 0. So taking K cap common, we will get Ax By minus Ey Bx. So this becomes like a general formula for A cross B when they are in two-dimensional. When A and B are in the xy plane, this becomes the formula. This is general formula for E and B in the two-dimensional xy plane. Similarly, we'll see the three-dimensional version also in a bit. Okay? But first, just understand the mechanism of this derivation fully. It is making use of the properties that we learned earlier. It is making use of the same properties. So just make a proper note of all this. And as you're noting down, make sure you understand each and every point. Okay. Just note down, making sure you understand each and every step. Ask me if there's any doubt. Yes, Shikhar, this is the formula when okay, Ananya, that I cross j is equal to k. That is from this definition earlier that we have seen. The cross product of unit vectors. This definition that we've seen earlier. This one. This is where it is coming from. So Ananya, this is where that I cross j is equal to k is coming from. Okay. You understood this before here. The cross product of unit vectors, or the base unit vectors. Is it clear, beta? Okay. So here we see that I cross j is k, and because of the property that A cross B is minus of B cross A, so J cross I becomes how much? Minus k. So we have just used these particular relations below here. Okay. So this becomes like a formula. Okay, now there's an easy way to relate this formula or remember this formula. Shortcut method to remember this formula is like this. Okay. So this formula A cross B equal to AX BY minus AY BX K cap can be related using something called a determinant of a matrix. Okay. So first of all, let us discuss a little bit about determinants of matrices. Let's understand this a little bit. First, let's see a 2 by 2 matrix. So that is given by an array of 2 columns and 2 rows. So let's say A1, A2, B1, B2. This is a 2 by 2 matrix. Now, determinant of a 2 by 2 matrix we have seen this in mathematics, I think. Okay. In solving of linear equations, it helps, etc. It becomes this diagonal minus this diagonal. It is given by this simple formula that it is A1 B2, yeah, minus A2 B1. Okay. So for example, determinant of, let's say, 1 3 4 2, okay, will be 1 into 2 minus 3 into 4. So that will be 2 minus 12, so that will be minus 10. So now we'll see how we will use a determinant over here to understand this. So therefore, this formula note Ex by minus Ey bx is, this term is the determinant of Ex by bx. Okay. So therefore, for two-dimensional vectors A and B, okay, in xy plane. The formula of A cross B can be just remembered like this. It is equal to, make a 2 by 2 matrix, then whichever vector you're taking before the cross product, उसके components को ऐसे लिखना है, and whichever vector you're taking after the cross product, the second one, उसके components को ऐसे लिखना है, and into k cap. So that further becomes ax by minus a by bx. So you don't have to remember this formula directly. You can just relate it with this determinant, and then you know how to solve that determinant. So I'll just leave you with some time to understand this. Okay. Okay. Okay, people, so hope this formula is clear. Let's just see the quick application of few of these. For example, if I have the vector E, which is, let's say, 2i cap plus j cap, and the vector B is I cap minus j cap. Now I have to determine A cross B. So I'll just use this method now, that A cross B can be written as a 2 by 2 matrix where A's components are 2 and 1 and B's components are 1 and minus 1 into K cap. So that will become 2 into minus 1 minus of 1 into 1, whole thing multiplied by K cap. So as you can see, this becomes minus 3 K cap, minus 2 of minus 1. So this becomes the answer. So it becomes very easy to calculate A cross B using this method when we have two-dimensional vectors. Okay. The earlier example we had seen, you remember, was E was 2i cap, B was I cap plus root 3 j cap. So let's just verify this method. So in this, write it as 201 root 3 j cap. So that is 2 root 3 minus 0 k cap, or that is 2 root 3 k cap, which we got by earlier two methods. But from this point onwards, we will always use this method because it's the easiest. Okay, so Ananya, this is just a formula that we use to find something called determinant of a matrix. Okay. So matrix, a 2 by 2 matrix is an arrangement of 4 numbers like this, which is related into 2 rows and 2 columns. Okay. So a 2 by 2 matrix is nothing but an arrangement of 4 terms into 2 rows and 2 columns. Okay. So these are the rows and these are the columns. Okay. So when we arrange 4 numbers into 2 rows and 2 columns, it is called a 2 by 2 matrix. And the determinant of a matrix is given by this formula. Okay. This formula is the determinant of the 2 by 2 matrix. So it is basically, you can think of this determinant like this. It is just related this way. So think of this term as the first diagonal and think of this term as the second diagonal. So it is the first diagonal minus the second diagonal. That is how we determine the determinant of the 2 by 2 matrix. It is given by this formula. So a 2 by 2 matrix is an arrangement of 4 terms of 4 numbers into 2 rows and 2 columns. And the determinant of the 2 by 2 matrix is given by this formula. It is the first diagonal minus the second diagonal. Like that. So hope this is clear now, Ananya. So determinant is a sort of a shortcut method that we use in number of places in maths. Okay. You will see that you use it while solving simultaneous linear equations also. But here we are using it to express the shortcut of a vector cross product. Okay. So this one becomes this. For example, if I have the values of A1, A2, B1, B2, etc. They are over here 1, 3, 4, and 2. Then the determinant of this matrix will become this diagonal term, which is 1 into 2, minus this diagonal term, which is 3 into 4. So it will become 2 minus 12, so its value will become minus 10. Okay. Similarly, if I put the values of the determinants terms as Ax, Ay and Bx, By, then that determinant itself will become this Ax, By minus Ay, Bx. So that's how it becomes a cross product. Okay. So that's how we are using this in these two examples below. So we have seen that we are using this general formula now for A cross B for these two. Yeah, I mean Kramer's rule is an application of determinant, but Kramer's rule is used as you would have studied in 10th for the this thing, solving of simultaneous equations. Whereas here we are using it for cross product. But yes, Kramer's rule also uses determinant, and here also we are using determinant of matrix. Okay. Now let's come to the 3 by 3 matrices. So a 3 by 3 matrix, it is 3 rows into 3 columns. So it's an arrangement like this. Yes, exactly. You use it in Kramer's rule for, that is correct, for solving linear equations with two variables. Now the determinant of this matrix is given by an entire process actually. First we break it into terms like this. So what you do is you isolate this term by removing this row and column. So this term becomes E1 multiplied by, isolate out the first row and first column. So you get B2, B3, C2, C3. Then similarly, like you've done over here, you isolate out this term. So you remove this column here, the second column. And you have to remember that the second term comes with a minus sign. And you remove the second column, so you're left with first and third. So B1, B3, C1, C3. And similarly, for the third term, you isolate this. So you remove out the third column and you're left with first and fourth. So first and second columns, okay? So it comes plus A3 to B1, B2, C1, C2. And next you just solve these as 2 by 2 matrices. So the final solution becomes E1 into this thing's determinant. So that is this diagonal minus this diagonal. So that is B2, C3 minus B3, C2 minus of A2 into B1, C3 minus B3, C1 and plus of A3 into B1, C2 minus B2, C1. So this term finally, it becomes the determinant of this matrix, which was this one. it becomes this. So if you're not familiar with this from 10th, then it'll just take you a little bit of time to get used to this formula. But this is all there is to it. There's nothing else to it. Okay? Yeah, that is how the formula works, but the way to remember it, that the minus sign comes because यहाँ इसका index 2 है, it's an even number, whereas इन दोनों का index क्या है 1 and 3 है, so they are odd numbers, so they come with plus sign. The middle term has an index which is even, so it comes with a minus sign. So that's a sort of memory tool to remember that there will be a minus sign in the middle term. Index is the number you are putting beside A, B, C, etc. Okay, so hope the formula is clear. So now let us see how we use this in vectors for cross product. So now coming back to cross product in component form. So we will see general formula for vectors in three-dimensional x, y, z space. Okay. So if the vector E is having the three components Ax, Ay, and Az, and the vector V is having the three components Bx, By, and Bz, then E cross B is given by this simple relation that you draw a 3 by 3 matrix. Okay. The first row is nothing but the unit vectors I, J, K. Okay. And the second row becomes the components of the vector E. So that becomes Ax, Ay. First, you take the second and third column. So Ay, Ez, By, Bz minus J cap, because remember always the second term comes with a minus sign, and with the second term here you'll get the first and third column. Second column is isolated out, so this Bx, Bz, and then the third term again comes with a plus sign, and because this is the third term, so you'll isolate out the third column and you'll take the terms of the first and second column. So Ex, Ey, Bx, By, and then further you solve this, so this becomes Ey, Bz minus EZBY I cap minus of EXBZ minus EZBX J cap, and then again plus of EXBY minus EYBX. So this becomes the final value. But you don't need to remember this formula. Instead, you can just remember it as this determinant of this matrix. So that's the shortcut method over here. So this is how we use the shortcut method of determinant of 3 by 3 matrix to determine the cross product of two vectors like this. Okay, note down this formula first. Then with a bit of practice, you will see this quite easy to work out. Okay, so let us do this with an example and wind up today's lecture. So for example, suppose I have the vector E, which is I cap plus 2j cap minus k cap. And I have a vector B, which is, let's say, 3I cap plus j cap plus k cap. And I say that find E cross B in component form, and secondly, magnitude of A cross B. You don't choose any kind. So here's how we solve the problem. So E cross B, they are 3 by 3, or they are 3-dimensional vectors. So you draw a 3 by 3 matrix, and the first row becomes the unit vector. vectors. The second row will become the components of E, which are I cap, 2j cap, and minus k cap. So 1, 2, and minus 1. And the second or the third row will become this B vectors components, which are 3, 1, and 1. So they become these components. Whereas this row was these components. Okay. Then further you break this up. So I cap goes with a 2 by 2 matrix. So it's the first column which is isolated. So you're left with second and third. So 2 minus 1, 1, 1. Then remember the middle term always comes with a minus sign. So isolate out the second column. So first and third. So it will be 1 minus 1, 3 and 1. These four terms. These two terms, 1, 3 here, and these two terms minus 1 and 1 here. And then the third term always comes with a plus sign again, and you isolate out the third column. So first and second column. So 1, 2, 3, 1. Here terms here. And next step, you just solve this further. So this becomes 2 minus of minus 1 into I cap minus of 1 minus of minus 3 with j cap and plus of 1 minus of 6 j cap. Okay. So this is becoming 3 I cap minus 4 j cap minus of 5 j cap. So this is becoming A cross B. Okay. So this is the first part. Now the second part, mod of A cross B. That is just magnitude of this vector which we have calculated, 3 I cap minus 4 j cap minus 5 k cap. That we can see is square root of 3 square plus 4 square plus 5 square. So that is 5. So this becomes A cross B, the answer to this part. And this here becomes mod of A cross B, the answer to the second part. Okay, so with a bit of practice, you'll be able to determine, you'll be able to solve these kind of matrix determinants very easily. And you can see that that's all you have to do for cross product in component form. Yeah, thank you. I will send the notes, and lecture 9's notes I have resent on the group, so you can access that also. Okay, people. So hope this method is clear. So that brings us to the end of today's lecture, and with this we've completed the concepts related to vectors. So there is one worksheet pending which will have cross product problems which you have to do, and we will also be discussing the exercises from your module over the next couple of lectures. So the last couple of lectures of vectors will be mostly problem discussion, where we'll be discussing the module exercises and the last worksheet number 7, which I'll be sending you today. Okay, so complete the worksheet 7 which I'm sending today over this week, and also start doing maximum questions from the module exercise number 1. Try this week to complete at least 15 of the questions. Okay, 15 to 20 of the questions. There are, I think, 22 questions. So attempt at least 15 of the questions from the exercise 1 of the module also. Okay, then we'll come to exercise 2, 3, and 4 also. So that's it. Thank you, people. Okay, all the best.